So here we go on question 3. On this problem, we've got 75 grams of potassium carbonate. So you write down your 75 grams of potassium carbonate. It is important that you be able to recognize that if it's potassium carbonate, it's got K in it, and it's also got carbonate. So we're looking at K2CO3. Oh man. All right, there we go. Do we need to change to moles? Yes, because it's not in moles. So we're putting grams of K2CO3 on the bottom. On the top, we will put moles because we're changing to moles of K2CO3. Is it important to write down both moles and K2CO3? Yes. All right, the number 1 goes to moles, and we have to add up the grams of K2CO3. So I'll refer you to the periodic table, but I know that potassium is 39, multiply by 2. We know that carbon is 12. We know that oxygen is 16, but there are 3 atoms of oxygen, so I have to multiply by 3. Again, on the side, I have 39 times 2 equals 78, plus 12, plus 16 times 3, which is 48, so plus 48. And I get 138 is the weight of 1 mole of potassium carbonate, so it'll be 138 grams. What's the next step? Remember the next step is the mole ratio step. So we're going to put moles on top, moles on the bottom. In order for the units to cancel, on the bottom we have to have potassium carbonate. On the top we put moles of what we're looking for. So what are we looking for? We're looking for hydrogen carbonate. So we're going to put moles of hydrogen carbonate on the top. Now what is the relationship? What's in front of the hydrogen carbonate? Looks like a 1. What's in front of the potassium carbonate? It's also a 1. So this is just a 1-to-1 ratio. That's easy. Now does it ask for grams? Nope, it asks for moles. So do we need to do anything else? It doesn't ask for grams, doesn't ask for liters, doesn't ask for molecules. It just asks for moles. I think we're finished at that point, because right now our moles of potassium carbonate have canceled, our grams of potassium carbonate have canceled, so all we have left is moles of hydrogen carbonate. That's what we're looking for, so the problem is set up. So now we have 75 times 1 times 1 divided by 138 divided by 1. So really it's just 75 divided by 138. Answer 0.54 moles. Did that on the calculator on the side of H2CO3. That was problem 3. Okay, problem 4. Notice it says unbalanced. Unbalanced. So we had to balance this equation before we start. So you look at the equation here, we've got 2 chlorine atoms. On this side there's only 1, so I'm going to put a 2 here. That created 2 hydrogen atoms. If you look over here, you got 2 hydrogens, so you're good. You got 1 calcium atom. There's 1 calcium atom over here, because that 2 only applies to the chlorine. We have 1 carbon atom on this side. There's 1 carbon atom, so we're good. We have 3 oxygen atoms. On this side, we got an oxygen atom here, and then 2 more here, so that's 3, so we're good. So that's all you have to do to balance the equation. All right, so now we have 455 grams of calcium carbonate. Calcium carbonate is this guy. What's the first step in stoichiometry? You got to change to moles. So we're going to put the grams on the bottom. We're going to put the moles on the top. And notice they're the same thing, top and bottom, because we're changing to moles of calcium carbonate. 1 goes in moles. And if you add up the weight of this, that's 40, that's 12, that's 16, but there's 3 of them. So 40 plus 12 is 52. 16 times 3 is 48. 52 and 48 is 100. Next step, mole ratio. So we have moles on the bottom, we'll have moles on the top. The mole on the bottom will be calcium carbonate. On the top will be carbon dioxide. All right, why is it going to be carbon dioxide on top? Because up here, see, it says what volume of carbon dioxide. And we started with calcium carbonate. Now, it asks for volume, so why am I not putting liters up here? Because this is the mole ratio step. So you're going to have moles on top, moles on the bottom. So what's the number of moles in front of the carbon dioxide? It's 1. and in front of the calcium carbonate is 1. So in this case, 1 went with moles, but that doesn't have to be true in the mole ratio. So once again, these numbers come from the equation. Now I need to find volume. So what's volume measured in? Don't you buy soda in 2-liter bottles? So we'll put moles of CO2 on the bottom, and we'll put liters on top. 1 goes in moles. Liters will be 22.4, because 1 mole is 22.4 liters per the mole map. So now the math, 455 times 1 times 1 times 22.4, divide by 100, divide by 1, divide by 1. So I'm going to just leave out the 1s and do 455 times 22.4. And I get 10,191. Then I have to divide by 100. So I get 101.92, or we could just call it 102 liters. So it equals 102 liters of CO2. I'm reminding you again about units canceling. This cancels this. Moles were canceled by these moles. These moles were canceled by those moles. Our final answer, liters of CO2. Next question. We have 1,500 moles of sodium bromide. Do we need to change to moles? So the first step won't need to be done because we already have moles. We do need to use the mole ratio. We use it every time. So we have moles of sodium bromide here. You put moles of what you're looking for on top, and you're looking for calcium bromide. So put moles of calcium bromide on top. All right, so the relationships are, there's in front of calcium bromide, looks like there's nothing there, so that's a 1. In front of the sodium bromide, there's a 2. Now, do we have another step in this question, or are we done? I think we're finished here because, see, it asks for moles. It doesn't ask for liters, doesn't ask for grams, doesn't ask for molecules. It just asks for moles. Isn't that what we have right now? Because these are canceled out. I have moles of calcium bromide, moles of calcium bromide. So we have what we're looking for. We are finished. Just do the math. It's 1,500 times 1 divided by 2, which is 750 moles of CaBr2. All right, I'm going to stop that so I don't get the movies too long, and I'll come back and do the last 2 questions.